surrounding Android game development. At the end, we have a couple of actual frameworks, mostly 2D frameworks, but also a comparison between them and Unity 3D and a couple other ones on there. So if you did vote for the 2D frameworks, the 2D cross-platform frameworks, that is at the end of this talk. So you're included in here, but most everybody wanted to know, just in general, how do I develop a game, and specifically Android? So this is more of how to design games, how to make games from a very high level, and then there's a couple things about Android-specific things like inputs and just running things on a device. So let's get started. I've included in the notes a couple of additional readings for getting started in Android-specific game development. So the first one is Android Game Tutorials. This is actually a Google, this is Android documentation, I should say, on how to do this in Android, so you can take a look at that. The next one we have is the ABCs of Android game development. They use one of the libraries that I'll mention at the end of this talk called libgdx, and that is a Java-based cross-platform library. They also do iOS, but the iOS integration is kind of weird because you have to buy a Mongo, or not a Mongo, oh, the name escapes me right now. It's what's the where they take .NET and try to put it on like Linux?
Oh,
yes, that one. Yeah, it starts with an M, doesn't it? Yeah, well, I have it in the notes.
You're talking about the Linux version. Yeah, it is Mongo.
Mono, yes, thank you. Mono. Mono is the language. Yeah, I've been working in MongoDB for...
It's the Linux version of C#.
Yeah, we'll talk about that. So that's the second link, and then the third link, I do believe, is... or actually, hold on, let me actually click on these to... Oh, I'm sorry, I got that backwards. So this one, the first one is the libgdx implementation, but it goes through all the things we'll talk about today and more. So start out with the game idea, create the project, and it just goes through all the different steps in individual tutorials. So you can skim through that and see if that's something that you want to dive down deeper into, and then they implement all that stuff in libgdx. Let's see, restart that. Okay, so that was that one, the ABCs of game development. This is another one. Let me just open this up. So this is this is native Android game development, and he goes through some of the drawing features of how to actually draw natively, and he designs a little game, and it's pretty neat. He shows you the code and everything of how to set that up. So here's the Android manifest file, for example. And I won't go through any more of it, but you can check that out for Android game development. And then finally is the Google Android documentation on that, so you can check that out. But let's start out from the top. So first off, I want to let you know that games are hard. They are probably the most difficult thing that you can do in computer science for many reasons. One, the programming's super hard, but also just getting them right. Because when you do an application like a web application, you have an input and you have an output, and those are expected. You know, you have the input and you have an expected output, and if your application has that expected output, you're good to go. And then you throw a little bit of user experience on that, a little bit of design, and you're pretty much good to go. Well, with games, you kind of have that same thing, but it's so much more, it's more of an art form. And so whether there's good art or bad art, whether your game is a good game or a bad game, that has nothing to do with functionally how well it runs. There's a lot of really highly technical games that are awesome in terms of functionality, but are terrible to play, or the story is just really bad, or something about it's bad that makes it a terrible game. So they're hard because it's, as I said, it's more of an art form. And for a good game, we need a story, some kind of story, a beginning, a middle, and an end. So I'll talk about these in length later on. Gameplay, so obviously just how the game plays, game flow, we'll talk about that in a second. And then replayability is really important because you don't want somebody just to play the game once and then forget about it, delete it off their phone. You want them to return to it because, when somebody sees them playing a game, they go, oh, what's that game? Oh, it's Flappy Birds, and here, give it a try. And you try it. You're like, oh, I'm terrible at this, but I'm going to keep playing it. And then you have to give the phone back, and then you go and buy it yourself, and that's how that makes $50,000 a day, is that kind of viral. Yeah, I mean, I played it for about 5 minutes. I couldn't stand it. I wasn't any good. I couldn't get past the first little pipe thing, and said, why would anybody want to play this game? But that's what happened. So anyway, kind of use this checklist. I mean, there are only 4 items, but use this checklist against your game that you may be making. I'll go through these in detail in a second, but make sure it has a story, good gameplay, good game flow, and has good replayability. I don't think replayability is a word because every time I type it in, either Word or Google Docs or whomever underlines it in red, but I'm making it a word. So start out with the story. Every game has some kind of story, right? Whether it's just a very thin, you have a character, maybe your father is kidnapped or he's killed by the bad guy, and then you have to go and chase that bad guy. Very, very thin stories like that. Or Mario Brothers, where the princess is captured, and then you have to go save her, and every time you go save her, it turns out to be, yeah, it's like, you would think in this, century, this millennia, Mario would have GPS and figure out the right castle. However, that doesn't seem to be the case, and every Mario I play is the same story. However, we still play Mario for other reasons, but it does have a basic story, and a fun story at that. And so we start with the story. We don't say, I want to start a first-person shooter game, though you might, but I don't recommend it. You want to start with the story, whether it's, Sam the pig is, he gets thrown off the back of the truck going to the slaughterhouse, and now he's lost in the woods, and he has to get back home, or something like that, right? And so that'll define the mood. First of all, he just escaped death, and now he's going to go back home. The genre of the game, maybe this is going to be a third-person view. It could be a first-person view, though that'd be kind of awkward if you're the character of the pig running around. And so maybe you control the pig by clicking on the map, and he walks over there. Or it could be some kind of role-playing game where your pig gets skills and that sort of thing. But that doesn't make sense to the story, so the story is going to define kind of the genre of the play, how that plays out. And then finally, interaction. So with mobile, we'll talk about interaction on mobile, but the story also will define whether it's going to be an action game, and so maybe you need to swipe on the screen to swing your sword, or tap on the screen to, maybe move your character around, or that sort of thing. So always start with the story. And the stories, as I mentioned, don't have to be super involved, but they do need to immerse the player in that world. And so either have a backstory or a theme. And so if you're putting your character in a magical enchanted forest, that might just be enough story to kind of immerse them into that world. But it's always good to have kind of characters and everything to extend that and deepen the level of storytelling. It absolutely needs an end to your story. So, why is that player playing the game? Are they playing it to save the princess, to avenge their father, to... I'm thinking of Ninja Gaiden, by the way, if you guys ever played that. So, what's the whole purpose of me moving my character or whomever through these levels? So that's part of the story. This part of the story that essentially says why you're actually doing that. And so the player is certainly not playing the game because the gameplay is fun. There are lots of certain first-person shooter games that it's fun to just go around and shoot, but there's only so much running around and shooting that you can do, right? It has to have some kind of purpose, some kind of story that defines what you're there for, and then finally the objective to complete. Because in Unity 3D you can just in about 10 minutes create a first-person shooter and then run around and shoot stuff, but that's really, really not fun after the first 15 minutes, 20 minutes. It actually is kind of fun for a little while, but so end to a level and an end to a game. So the end to a level, there are obviously many levels to a game, and then finally the end of the game itself. And the reason I bring this up is because with our level, we want the user to have an end, some kind of completion of each step in the game. So maybe they, let's use our pig game story to, the first level is, okay, now he's in the road, there's cars coming, he has to get off the road and somewhere safe. And there's an end to that. And then once he completes that, he goes on, maybe he's in the woods, and now he has to get out of the woods or through the woods, and then there's an end to that. And this is just a sense of completion for the player, and also to allow them to save, because with mobile, they might only have 10 minutes to play, 5 minutes to play, even less than that. And so you need to have these actually be shorter than on a console, for example, where a player might play for 3 hours straight, where there's no end, like the the Elder Scrolls series, Daggerfall being one of those. Is, you could just play and play and play and play, and there's no real ending, though there are endings to quests and that sort of thing. Assassin's Creed is another example of kind of an open world kind of gameplay where you could just keep playing, but there are still endings to the quests that you are on. So make sure you have endings to all those different things. And then let's get into gameplay a little bit. So we want to introduce the player to the game, and so this might be a little tutorial or maybe a little of a backstory. This is really important because this goes into storytelling, where you can't just slap your player into the game and say, okay, go off and do whatever, right? Because it's like, why? What's the story behind it? Why am I here? I'm not playing just because it's a fun game to play. So introduce them to the game. Introduce them to the backstory, or introduce them to the world that they're currently in. Try not to just slap up text to the screen and say, okay, here's our backstory. Try to have some kind of scripted animation where characters are coming through. Maybe a monster comes through, destroys things, and that'll introduce the character or the player to the game. And then the second point here is introducing them to the controls. This is a real pet peeve that I have when I start playing games. I don't know how to move the character. I don't know how to fight, how to attack, how to jump, and I'm just kind of mashing buttons to figure those things out. So have like a maybe little mini tutorial in there to just say, walk over here, hit this button, go to this store, purchase this item, that sort of thing. So that's a super important part, because again, you're just dropping them into a story. You don't just come into like a novel and slap into chapter 3 because you miss all the context behind it. And then with a book, you know how to read, but with a game, you might not know how to move around in that story. So get them to play more. This is very, very important. This kind of goes back into replayability. But for the gameplay, you always want to have a call to action for the next thing. So, for example, in Assassin's Creed, you might walk around the world for a while. You might pickpocket people. There's lots of things to do outside of the quests. But once you complete a quest, there's always the next quest. There's always like quest 2 of 5, or increase your skill. So you have to keep doing quests, or you meet a character and they're like, here's all the quests, and these little quest pins show up on your map, and then you go to those pins. And so there's always something more to do in those games. There's always something, again, when you complete the quest, it's always like, all right, congratulations, you completed the quest, here's your reward, but look, there's all these other things, and it keeps the player going and going and going. With games like Farmville, for example, that doesn't really have any end. It's just like and I've never played, so correct me if I'm wrong, but you have these crops that you're growing, right? And then you have to come back like 3 hours later and make sure you harvest them, and if you wait like a half hour too late, then they spoil or something like that. That's the next call to action is, okay, I've harvested the crop, now I have to replant the crop, I have to water the crop, I have to like come back and do something, right? And the way that we accomplish this a lot on mobile is push notifications. So games like Star Wars Heroes of the Galaxy, I think it's called, they will send you a push notification when your energy that you use playing the game comes back, and it says, okay, now you have full energy. And they call that a cool-off timer. So you can play the game only so much, and then the timer or essentially your energy or whatever they call it goes down to zero. You can't play anymore, and then you have to wait, an hour, 2 hours, and then your energy rebuilds over that time period, and then they'll send you a notification on your phone. A little thing will pop up and say, oh, this is not what it says, but it says, Darth Vader's coming to destroy the galaxy. Your energy's full, come play, or something like that. I haven't played the game Temple Run in probably a year, but like every 3 months, it seems, I get this little notification of, hey, come back and play. And so again, that's the next call to action for your game is we've realized you haven't played in a while. Come in and play us. And so, yeah, there's lots of ways to accomplish that. And then we have game flow. And by the way, if you guys have any questions, just raise your hand. I'll be happy to stop and talk about these in more detail. So the game flow is how the game proceeds through its story and the players through the levels are seen. So we kind of talked about this a little bit, but how the game actually flows through that story, how it proceeds through the levels and the scenes. So is it kind of clunky when I complete a level? Is it okay? I've completed a level and then it just drops me into another level. So example, I'm in a forest and then I get to the end of the forest and now it drops me into a dungeon and I'm like, why? That didn't flow very well. There's no segue into that next scene. So how do you make that flow happen better? You can put in maybe a cutscene is pretty popular to do. Maybe some scripted animations where a monster comes in, picks you up, grabs you, and brings you down to his dungeon or whatever. So how that all flows. But also, that's between levels, but also between different pieces of those levels. So good game flow doesn't jar the player out of the environment. So again, you're in an enchanted forest, and then the next scene you're in a dungeon, or even worse, even crashes. Like if the game is crashing, I'm playing this game, I'm really immersed in this enchanted forest, and then now I'm looking at the home screen of my Android device, and that's like, oh wow, okay, maybe I put it down, or maybe I restart it, and so that's pretty jarring for the player. But anything maybe a little bit more subtle than that, maybe a transition from one scene to another, where I'm in an enchanted forest, and then the next instant it pops in, I'm in a dungeon. Again, maybe there's a cut scene, or maybe you have the player walk into the tree hollow that you found that then goes into the dungeon, something like that. So it shouldn't also frustrate them. So if they're playing like Flappy Birds, it's very, very frustrating where I don't want to play it anymore. However, that game is probably the exception to that rule where, the more you frustrate the player, the more they want to come back. But you don't want to frustrate the player in the gameplay without a purpose. And so Flappy Birds the whole purpose is to get through those pipes. And if you can't get through the pipes, that's the purpose of frustrating. Is like, I really want to get through these pipes. And you'll play and play and play because you want to prove yourself that you can get through those. And after about 5 minutes for me, I'm like, this is a waste of my time. I'm moving on. But for other people, they get really obsessed with that kind of stuff. So you want to capitalize on those people because not all your gamers are going to be the same. So the people that are frustrated, that want to, just get through that fifth or, I don't know, see how far they can get, those are the people that you want for that particular game. And so finally, it proceeds seamlessly from one step to another. I kind of already talked about that. Replayability. You want the player to be able to play the game over and over and over, so I kind of stepped upon that a little bit here and there. But I want to especially call out if all the levels share the same type of interactivity or gameplay. And so, for example, Mario, you're just jumping, you're walking back and forth and jumping on things. That is pretty much the only interaction, because when Nintendo came out, there was only 2 buttons, and I think one of the buttons is run, and then the other one's jump. And so you're jumping on things, but it's one of the most fun games ever, right? Because you're actually designing the world in different themes and different characters and enemies, different things you can jump on. So yeah, you're just jumping around, but whether you jump and you hit your head or you jump on something, they have different forms of playability in there. So the replayability of Mario is awesome. I mean, you could play the 1982 game, I think it is. Depends on whether you count the Japanese release or the U.S. release of it. Super old. Anyway, I don't know what the date is, but everybody can still pick up a original NES and play Mario just like, it's fun. It's replayable. And so take those concepts and try to apply them to your game. It might not be, it depends on the game, obviously, but put in things that if the player is coming back to that game, whether it's back to that same level or, again, the interactivity is the same, you're just jumping around, try to vary up how that works. So maybe put in some level of randomness, so maybe random characters come in at random times rather than something that's strictly scripted that are coming in. All right, so let's get a little bit more technical that's the whole conceptual thing, but how does a game actually work? So the components of a game. Now we have a game loop. I'll get to that in a second. We have game state. So what state the game is in, playing, paused, if you're in a scene, or if you're loading. The game logic. This is probably where you're going to spend most of your time. The game physics. So almost every game has some type of physics, whether in Mario it's gravity, or you're in a flight simulator where that's going to be really physics heavy, or a space shooter, or even just a game of chess has some kind of physics because you're moving pieces around, and whether those physics are just move from A to B and stop when you get there, but maybe slide as you're doing that. You're sliding and you're maybe having some kind of easing in or easing out of that sliding motion. It's not just a static linear movement from A to B. It's kind of maybe accelerating and then decelerating as I get there. That's a form of physics. The collisions. So if you have two objects colliding and you want to get notified about that, whether that's going to damage your player or it's going to cause it to bounce off and go in the opposite direction, those are collisions. And then you have user input, which on Android we'll get to in a second. And then artificial intelligence, which we won't get into today. There's actually a class here at BSU, I believe they still teach it, called AI, artificial intelligence, and that'll talk about all those concepts in depth. Has anybody ever taken that one? No? What did you think about it?
I thought it was pretty interesting. Some of the things he was talking to me about, I wouldn't mind taking it, but I just didn't have time to.
Yeah, it's not only artificial intelligence, not only for games. You guys probably seen a lot of the stuff that's coming out of Google and other companies for artificial intelligence, data mining, things like Siri and Cortana, these digital assistants that are talking to you or are aware, context aware, that sort of thing. So AI will be a huge thing coming up here in the next decade or so. Okay, so let's dive down deeper into each one of these concepts. So we have the game loop. So this is an infinite but breakable loop that continuously evaluates, reacts, and draws the game world. So this is where we get the concept of frames per second. It is essentially how many times the game loop can execute per second. So usually a good, what we call FPS, frames per second, is roughly about 60. Though if you can get 90, that's pretty cool. Do you have something to argue about that?
No.
Okay, you just kind of made a face.
For some reason, I was thinking 32, but I wouldn't think of something else.
32 is pretty good. So film, to give you kind of a context,
Yeah, that's what it was.
when you're watching a movie here in the U.S., because it's different in other countries, the frame rate for that is 29.97. I don't know why it's 0.97. It just is. But 29.97 is the frame rate, so roughly 30 frames per second for film. And then with films that are high definition and frames per second, they've upped it sometimes to 60 frames per second. So GoPros will do 60 frames per second. So if you're skiing down the mountain, doing really fast, actionable items, then you get more frames per second so that it's less blurry and it's a lot more crystal clear. And so that's what you want in your game, is to have a high frame per second. And that's kind of defined by your game loop, more or less. It's a little bit more complicated than that, but essentially every time your game draws the screen is once per game loop. So for example, if you're moving just your character across the screen, what's going to happen is you're going to start at this, let's call it X position, and the next frame you're going to move here, the next frame you're going to move here, or maybe the next frame you don't move because it's so quick, it's, let's say, 90 frames per second, that it won't move depending on how slowly the character is moving. It might not move for 30 or 40 frames, but other things are happening. Maybe the enemies are coming in faster, that sort of thing. So we have the concept of time and frames. And so when you are animating objects from x to, or x prime to x2 or something like that, so one position to a next, you do that over a set period of time, and that depends on the way that they used to do that actually was clock cycles. And so if your CPU was really, really fast, your character would move really quickly from point A to point B. And then as, because I remember playing games on really old hardware, XCOM was one of them where your character would move really quickly, and then as the machines got faster, he would almost instantly appear over there. And then as they got really fast, it was just unplayable because as the enemies were shooting at you, things would just happen and you never see it because of they were doing it on clock cycles. So if you have a for loop or a while loop, for example, which I think I have later on in the notes. If you have a while loop that's just continuously running and you're drawing things that that's going to execute every time. And so we have a concept of delta time, and what delta time does is the change in time. And so if the time has changed 100 milliseconds, then move the character just this much instead of per clock cycle. And then the game loop also works with game state, with the game state machine to determine how to function. And what the game state machine is, so this has various states to determine which part of the game you're in. So whether you're on the menu or in the loading state or in the gameplay state, and then while you're in the gameplay state, you might have other states as well. So these are usually referred to as state machines, and this is a pretty deep concept in computer science. We'll talk about this briefly. But these are usually implemented in subclasses of a parent state class with overridden methods to control basic functionality. And so an example of that, here's just a basic base state machine that I have. There's one called game loop, which will execute every time or as often as it can. And then we have another one that's called on pause. And then we have one that's called menu state, which extends the base state machine. And so we're going to override that game loop to 1, show the menu, and this is going to happen 60 times per second. And then also we're going to register the listeners. And we're not always going to register the listeners, but for example, we might have, actually it should be called like listen for listeners. It's probably poorly named, but essentially you're going to be listening for input, whether it's a key up or a key down or a mouse click. That's what that second method does. And then when the game is paused, you're going to hide the menu, and then you're going to unregister listeners or stop listening for input or specific input. That's just one example. And so what you can do is you have your main application or game pointing to an instance of this state machine, and so it's going to call this menu state machine, it's just going to call its game loop, right? And so when you're ready to transition, you take that menu state object out and replace it with something like a play state. And so here's our play state code. And it looks very, very similar, but instead of drawing the menu, I'm going to draw my scene. And so this could be your character, this could be enemies. That's all defined in that game logic in game scene. And then instead of, I should really name this not register listeners, but listen for input or something like that. So I'm going to draw the scene, and then I'm going to see if the keyboard has been pressed or the mouse has been pressed. And then if so, I'm going to handle that logic. And then when the game loop comes back around and it's going to draw my scene, it's going to take that input into account and draw it differently. So it's going to move my character or whatever it needs to do. So a very, very basic example. But let's see. Yeah, so maybe the input for that is I hit the escape button. If I hit the escape button, I take that object, the play state, I pull that out of my overall game loop. I put my menu object back in, and now instead of drawing the scene, it now draws the menu. So this is state machine stuff. And you can use the same concept for player or enemy AI. So for example, the AI state machines, one could be I'm running away, and so you take that state machine and you plug that in, and on its game loop, it'll handle the logic to run away. And there's different algorithms to, the player's over here, I'm the enemy, so I'm going to run away. Or then you have a state machine that runs toward, so you take that state machine, plug it into your enemy, and now the player's still over there, I'm going to run toward him or her instead of running away. So by having these different state machines attached to your different enemies or player characters, that you can control their behavior without writing a whole bunch of like methods and run away or this and then calling that and then checking or that sort of thing. You can just essentially take an object. You can almost think about it as a different type of brain. So you're taking like the brain and putting a different type of brain in your enemy or into the enemy character and then controlling how that works. So again, like a flee or a fight or a attract type of thing. So this would maybe what our main game loop would look like. So the overall surrounding game loop that's being called. So I'd have a method or a member in here called current state. And as I said, we switch these out. So this is our game loop. It's just a while loop that has a variable or a boolean in here. It's called isPlaying. You set that to true, and this will execute as many times as it can. And then we have that current state, and we call its game loop. So I showed you that before. And then I have a switch statement in here to get the current user input. And so maybe I get that from the current state game loop, or maybe I have another method in here. But somehow I get the input from the user, and if that user has hit the escape key, we change the current state to a new menu state. So again, we're creating a new instance of that menu state and then applying the current state here. And then when we come back through the loop, we then hit that current state. In that case, it would be the menu state's game loop, and it would draw the menu instead of drawing the game scene. And then maybe if I hit the space bar in this game loop, so it'll continually draw the menu until it detects that one of the current user inputs is the space bar. And so when I hit that, I change that current state to a different state machine object, in this case play state. And that game loop then draws the game scene, that sort of thing. So you can see how those kind of components can be interchangeable. And again, you can apply that to enemy AI. And that's actually where I learned this pattern from, is the AI stuff portion of it. So state machines are wonderful. That's a design pattern that we use. And so for the game logic, this can become spaghetti code very quickly without the proper software engineering pattern. So I mentioned one is the state machine. But we have other ones. We have singletons. So I can't stress this enough. I love singletons. Health, for example, ammo, loot, experience points, etc. can be stored in a player singleton. So again, just like our buildings controller, that's a singleton, or a location controller, whatever, you can do things like player.ammo plus equals, which will add 50 to whatever number the player ammo is currently at. Or if you detect a collision or a bullet or something hitting that player, or maybe he falls a certain distance, being able to access that player information from anywhere in the application by calling player.health. And so maybe the enemy or the bullet or some other object is controlling or influencing the health of the player, so you have health minus 10, for example, if that collision's detected. So you don't have to pass the player object around to all these different things. Like, for example, all your enemies don't need to know about the player, because if you have 1,000 enemies, if it's like some kind of swarm game, trying to pass that player instance around to those 1,000 objects, rather than just calling player.ammo, which would be a static variable in there, and just doing it that way. So I love singletons, and you can also do this for a game value. So instead of doing player.ammo, we can do game.sound or sound effects, and that would be a Boolean value to turn music off and on. And again, we can set that from anywhere. Factories. So again, I love factories. So factories take an input, and you have some kind of expected output. And so levels could be created in a factory, or enemies could be loaded via factories. And so the first example I have is a level loader. And this is pretty much what you find in Unity, very similar to this. A little bit different. I've kind of customized a little bit more. But you have this level factory, and then you call this static class method called load level, and you just give it the name of the level. Maybe it goes and looks up a file with that name, or maybe from a list, it doesn't really matter, or maybe this is the text that appears at the top or something like that. And then you pass in a player difficulty that we get from the game singleton, for example. And so by doing that, this level factory will go and based on the difficulty, for example, if it's a hard difficulty, maybe it places more enemies in the level, or if it's easy, maybe it places things differently. And so you don't really care. You just pass it a bunch of options, and then it passes you back the level that you then use in your game. Another example of this is the enemy factory. So enemy factory.spawn enemy, and we're going to give the enemy type. And so I'm going to be a little bit generic here. I'm going to say create an orc. Or a goblin, so in this case it's a constant that we pass in, and then the next value we have is the location. So this is an XYZ, so X30, Y100, and these are just coordinates on the map, and so this is going to spontaneously or dynamically allocate a enemy somewhere on your map at those 3D coordinates. And then you pass in some attributes, and I'm just passing this in as kind of a complex object here. Health equals 300 and level equals 32. And so maybe this is in the logic of my level loader, or maybe you're having these guys spawn sporadically in your logic, and so you can give them different health and that sort of thing. What this method will pass back is an actual enemy object that you can put in your level. So that's how factories work in games. All right, so engineering a game. Use your language to its advantage. C#, for example, has a yield method that returns and comes back, and it's a nice way of doing asynchronicity. Don't worry about it if you're not familiar with that. But that's a language construct that we can use to better engineer our game, and then also use your patterns. Don't just throw a bunch of code up on the screen. And I guarantee when you're talking in interviews and everything, with the better software engineer based companies, they will ask you about singletons and factories or what's your favorite design pattern. I've gotten that from a lot from students. It's like, yeah, I just had an interview and they just asked me that exact question that you taught me singletons like 2 weeks ago, and sure enough they asked that question. So yeah, use them because it'll make your life so much better. And then as I mentioned at the beginning of this talk, there is almost nothing more complex than a game's logic. You can imagine with all these enemies running around with artificial intelligence, whether that's really, really complex intelligence or just, like Pac-Man style, where you're going to have the logic of you're always going to head toward Pac-Man, or you're going to try to head him off, or maybe the opposite where you try to run away. That's a very simple example of AI, but you combine all these things together, then you have a very, very complex application, more so than a web application that you probably put together. Maybe not always, but sometimes, most of the time anyway, I'd say. And then we get into physics a little bit, and so for the next class I'll kind of show how all these piece together. This is more of the conceptual talk, right? We'll talk about physics and show you kind of how that works in Unity 3D. And so almost all games have physics to some degree, as I mentioned. And for this, though, what I recommend is using a third-party physics engine. You don't want to have to figure out, okay, if gravity is 9.8 meters per second, and my level is this tall, and this is the meterage, and this and that I have to drop the ball and accelerate it. And so as it's moving on the z-axis, for example, that I have to accelerate it by some, don't worry about that. Just for the third-party libraries, most of the time you just take that object, like that enemy or that ball or something, and then you attach what's called a physics body to it, and then the game handles the rest of it. And you tell it what gravity is. You might tell it a gravity on Earth with 9.8 meters per second, or gravity on Jupiter, which will probably crush you. I don't even know what gravity on Jupiter is, but we know that there is an android constant for that, right? As well as the Death Star, the first one, with the gravities on the Death Star. So you can look up those constants if you're doing native, or you can just look them up, and they have third-party. The third-party physics engine not only takes care of gravity, but also if something's sliding on a surface, for example, how that slows down, if it collides with something, what the bounce rate is, or the the stickiness is. So just don't try to do it yourself. Just go and download a third-party library. So how do collisions work? Really quickly, so we have 2 objects here, one in red, one in green. These are the coordinate systems for them. So just on a 2D surface here, and for that bottom image, how would you be able to tell that those 2 objects have collided with math? So you'd probably get the dimensions of them. And so, for example, at 15 comma 4 here, this is where this line intersects with this line, for example. You could certainly do this corner and this corner. And so there's ways and algorithms to figure out if two objects are actually two squares, two circles are overlapping each other, and thus a collision. But when we get into circles, for example, is this considered a collision? Probably not. So you wouldn't use that same algorithm. You'd instead of doing 4 points of a box, you'd probably do a single point and then a radius, and then seeing if those radii overlap. And then we have basic shapes like this one, which is just kind of a blob, and how we do that. So we take the original shape, which is in number 1, and we kind of draw a grid system around it. And then we color in and we define that the grid, so the second grid item here in this row, that's going to be on. And so if any of those, if we go back to this example, we do that same exact thing, but we do it many, many, many times over. So that first box, is that colliding with another smaller box? And if so, then yes. If it's on this box, then no, it's not a collision. You can define whether this corner piece here is on or off. In this case, we don't bother with it. So that's just what that illustrates. And then finally, for this we have user input. So on a mobile device, we have a tap. We have a long tap, so that's tapping on the screen and holding it there. We have a slide, so you're sliding your finger up and down, left and right. This is often used for like first-person shooters, where you move your thumb up and the player walks forward. You move it down, he backs away. You move it left and right, and he strafes right and left. And then maybe you have the other thumb that fires or something like that, or even looks up and down. So that would be more of a slide. And then you have gestures, so a pinch, a pull, making shapes, so making a circle with your finger, making a square, making a star might be an input to your game, making an arrow like a chevron or a down arrow or that sort of thing. Those are all gestures, and they have libraries that actually detects those shapes. I had a student last semester that he did a Unity game, and he also did the same thing for Bronco Apathon, but he had this game where you spawned characters through this wizardly type thing, and you draw a star, and that would create a wizard, or you draw like a dome type shape, and that would be like a gravestone, and that would spawn a skeleton or something like that. So the shapes corresponded to which creature you were going to spawn, send them out and attack the enemy. And so I thought that was brilliant, but try to incorporate those in some kind of interesting manner into your game. And then we have orientation. So this is the orientation of the device. With race car games, you're kind of using it as a steering wheel, going back left and right, forward and back is also, so how the orientation works for that. And then the hardware buttons. We have hardware buttons, volume up, volume down. You can use that in your game, maybe as a special feature, that sort of thing. And for this, we have artificial intelligence. I won't get into it any more than state machines, but you can read this book. This is the book that actually I got that I was working through. This is in C++, though you can take that C++ code and apply it to Java very easily, or Unity code, which is in C#. And it's a great book. It's not dry. I mean, if you like algorithms and artificial intelligence, highly recommend this book. This specific toward game AI, but it's awesome if you're interested in games. Okay, so when we talk about Unity next class, I want to kind of throw these, not only Unity, but also 3D creation, so Blender 3D, which, by the way, when we talk about it, this is a motorcycle model that I've been working on, and it's not yet completed, but I am going to take this, put it into our game, and maybe drive it around. And so I've modeled this in 3D, and I will incorporate that into Unity and show you how easy it is. Not the modeling, but just the whole thing. And so you can download your 3D models. But that model, that shape there, that geometry, that's called a mesh. And so that's our first point here, is that's your 3D object's geometry. That has nothing to do with the material, which is the skin or the texture of your mesh. And so if you go back to our Blender example, you can see that there's really no, I mean, there's a little bit of color to it, but until you turn on the rendered mode, you'll actually see that I have it colored. It's colored, and if we zoom into, this is really hard on a touchpad. Oops, too far. And what it's doing is it's rendering, and that's why it's all blurry until you stop rendering. This is a pretty good example. So a material for our mesh is the vinyl seating, the plasticky kind of shiny coat that we have here, and then maybe the metallic material that we have on the, this is a key for the, it has a trunk, by the way, the back seat opens up, and you can put like basically your insurance papers back there. It's not too big, but that's a keyhole. And so the material that we applied to that is a metallic material. And then we have a shader, which is an algorithm that takes an incoming photon and how that reflects, scatters, or gets absorbed. So if you go back to our example here, we have, this is all based, the material has shaders that make it, we have a glossy shader, we have a matte shader, and so we use the glossy shader and a couple other different types of shaders, like a metallic shader, there's probably one in there, to make that metallic looking keyhole. And so what that's doing is it's taking those photons and bouncing them right back, whereas the vinyl, because vinyl is a little bit, it looks more like matte, not glossy, is essentially the best way I can describe it. That's going to absorb your color and actually scatter it all over the place. And so because this is a black color, it'll absorb it. Because it's a matte finish, it'll scatter it. Whereas the glossy kind of is in between, where it'll kind of scatter and absorb it a little bit. And so that's where you get the glossiness of there. And then the metallic is almost 100% glossy, where it's just going to take that photon and bounce it straight back at you, and that's why it's really shiny. And so in game development, we need to know about these things in order to make our game, or at least our 3D game, look really, really powerful and really beautiful. And so the next concept I want to run by you before next class is our Unity prefab. This is more of a concept in Unity, but this is a combination of meshes, materials, shaders, animations, scripts, etc. There's a whole bunch of other things that apply to allow the developer to, just drag and drop these items onto the scene and have them just work. And so a prefab might be a third-person character that you're taking and you're just dropping onto the scene. You hit the play button, and then now you can run your character through the scene. Let me show you this really, really quickly with Unity. Oops. Let's get rid of that. Let's go to our scene here. So here's an old truck. You can see that I've just dropped this into my scene. This is not a prefab, but if I click on it, you can see the mesh, which is the geometry of it. You can see it's all triangles. And then if I open up, I downloaded this dungeon level, and everything's all prefabbed for me. And as we move through our scene here, you can see it's a nice little dungeon. We have lights, and the lights have, they're bouncing off of the stone, and the stone has shaders on it that reflect a little bit but also scatter the light, that sort of thing. You can see the lights in here, but if I hit the play button in Unity and give it a second, you can see that there's a character, and he's just kind of waving back and forth. He's not colored in. I guess you can't see that too well, but if I move around the scene, there he is. You can see him a little bit better in the light. And I messed up the thing. It's kind of, the camera's messed up or something. But you can see I can walk around my scene. I have done zero programming. I just downloaded this dungeon scene from the asset store. I can jump. And you can see our character, his name is Ethan, by the way. I didn't name him. That's just the name of this character that Unity gives you. You can see as I move around, he's kind of swinging his arms as he's, that sort of thing. So that is Unity, and we'll talk about that next class in detail. And then real quick, I'll post these notes, but libgdx. If you're thinking about starting a game and you want to go off tonight and pick out your next library, because I made you really excited about doing games. This one's written in Java, so that's helpful if you already know Java. It's pretty much all platforms. It's very low level, so you have a lot of control over it. It's very heavy in the OpenGL support, so again, really low level, but it's also open source. The cons of it, the iOS costs money because you have to have a mono license for it. The cons is it's low level, so it might not be for you if you want to stay high level. And then the iOS emulator support is pretty much non-existent. Unity 3D, I just showed you that. This has awesome 2D and 3D. The prefab stuff that I just showed you is super awesome. The support for third-person and first-person type games is just built in, and then the asset store is just wonderful. You can go and download those dungeon-like things. Some of them cost money, some of them don't. For an actual license, it is pretty expensive. It's $1,500 per platform, so if you want to do Android, it's $1,500, iOS is $1,500, and then the desktop is also $1,500. So when all is said and done, that's $4,500 to deploy to all these different platforms. But you can use the free version. So if you don't want to, basically the cost is you remove the splash screen from the beginning of your games, and there's a few other things. But I highly recommend using it because there is a free version. You can use that to publish your games. Highly recommend it. And then there's Cocos 2D if you're into 2D. If you just want a 2D game, Unity 3D also does 2D. And then this is done in C++, Lua, and JavaScript. And then Corona, which is done in Lua. You can check out those links at the bottom. But that's all I got for you guys. Hopefully that kind of kick-started your interest in games and how to develop games. And then next class we'll talk about actually developing a 3D game. So thanks for coming out, and I will see you next time.